Welcome to the Data Future channel. This is Shekhar and I am a data scientist. So in this particular session, we are going to develop a machine learning model which can predict the sales of different products based on the multiple attributes of the product. So this is kind of regression model. So why regression? Because our target variable is a continuous value. So how it is continuous, we will check. Okay. Yes. So let's get started. I'll show you the data and then we'll discuss the things. So initially you have to import all the required libraries or the models because these are the dependencies. The pandas, numpy, seaborn, matplotlib. Okay. So next one is we'll see the data. Okay, first. So you have to load the data by using a pd.read underscore CSV. So here you will see these columns. And finally, the thing is that you have to predict this column, the item outlet sales. Now you can see that looking at the data, there are some categorical columns, there are some numerical columns. Yes. So we have to understand the data first. We'll check the shape of it. 82, 8523 records are there, rows are there, and 12 columns. Then list, these are the list of columns. In the list of columns, we must understand what is the significance of each column. The first one is the item identifier is unique product ID. Then item weight is weight of that product. Fat content, whether it's a categorical one, you can see here. Okay, and simply I just take here so that we can easily see these things, and I'll take only one. Okay. Yes. Now next one is the item types is the category of the item, whether it is dairy products or something like that. MRP is the price. Outlet identifier is the code of the outlet. Then outlet establishment year is there. Then size of the outlet is medium, small. Okay. Then outlet location, it's a tier 1, tier 2, or tier 3. The location based on the city, we can say. Outlet type is the whether it is supermarket type, okay, type 1 or uh, type 2 or type 3, something like that. Then finally is item outlet sales. That is our target variable. So this is all about the data. Then we'll check how many columns are there which are categorical and which are the numerical one. From here you can easily find out these things. But from the statistical points, we need to separate out these columns, numeric and categorical. So here you will get all the idea about your data set. Then here some values are missing. You will see. Notice here. But if you can check it here, you will see item weight and outlet size is having a maximum missing values. So we'll do the some describe statistical information of the data by using a dot describe function where you will get the 5 point summary, 5 number summary here. You will get the mean, standard deviation, 25th percentile, minimum value and maximum value here. Okay, so I'm separate out the categorical value columns and the numerical columns. I'm using here select underscore d types and include object, and I'm creating the list of it. Okay, the list of categorical columns, list of numerical columns. So it will be easy for me, right? Now I'll check how many unique values are there in the categorical one. Okay, so the item identifier is the product. So there are 1559 products are there. So because of that, this is more. Rest of all are the having less categories. Okay, so we'll check that based on the value count. I'm running a for loop. Here, no need to worry about this. So item fat content is there, low fat, regular, LF, reg, low fat is there. So item type, then outlet identifier. So all these values, the value count or the for category column, the categories and its count is given, right? You have to pre-process the data. You have to check the duplicates if there is any duplicate values. So it is saying there is a no duplicate values, but there are some null values are there. But how to fill these null values? These null values will be filled by the mean value of this, or but on the basis of what? The items. So here there are 1559 items are there, and based on that we have to fill the null value for that particular item null position, right? So it is a difficult task. Now you can see here, suppose this item is there, item product is there. Here the null value should be filled by the average value of this particular item, right? So this is the critical task. So for that we will do one thing. So first we will calculate the mean value product wise, means item wise. These are the mean values, and we will create a dictionary of it. I'm using a dictionary by using a dict and zip. Here I am creating the list of these two columns. We know that how to create the list of these two columns, and now the dictionary is there. So that is very easy for me for the mapping. And I'm using here the for loop, and I'm checking if there is a null values, then take the mean value from the dictionary and insert there. Okay, so likewise I am running this for loop, and uh, uh, it's a row wise I'm iterating. So you will check. Now most of the values are filled, but these values are not filled because these are the unique numbers. Okay, and these unique products are having null values, so no issues. We will drop these items. Then same thing you have to fill it for the outlet type, because um, outlet size is also having nulls. So first we will create a dictionary of mode. Okay, here. So you will see the dictionary is having supermarket is small, means here I am using a mode value. Mode means most frequently occurring value for this, and I am putting this outlet size based on this supermarket type 2 grocery store or this. And for that I am running a for loop here. So finally what you will get uh, here, there is no null values present in the outlet size, right? It's a great thing. Now the thing only null values are present, these four. So directly I am dropping it by using a drop NA. Yes, now there is no null values are present in the data. Okay, fine. But in the data, if you check, there is a item visibility is 0. If you can check in this describe function, item visibility is there. The 0 minimum value is 0. So what you have to do? So you have to replace this 0 with the mean value. Okay. So mean value, you can see here, there are 526 records are there where the visibility is 0, but I'm replacing it with um, mean value of this. So for that I'm writing this code directly there. I'm using a replace function. 0 is replaced by the mean of this, and in places to mean the same value. I'm using a dot log here. Yes, now you will see the item visibility is 0. There is a no value, which is where the item visibility is 0. Right. So item fat content is there. So here you can see there is some items are miscategorized because here LF is the low fat, RAG is also regular, and low fat is also low fat. So you have to refine this, because everything you have to bring it into two categories, low fat and the regular. These or the short forms are used. So for that, what I am using a replay again, and I am using this mapping so that you will see the item fat content will be only two, low fat and the regular. Okay. Yes. Now we have to create the new attributes uh, here, because you will see the identifier is here. The identifier is FD, NC, and DR, these things. Okay, so here what I'm doing, I'm extracting the first two letters of this item identifier. So, and I'm mapping it with the standard categories, like FD is food, NC is non-consumable, and DR is the drinks. I'm using a map function here, and you will see our new attribute is there. That is the new atom type, this one. Yes, now our data is ready. Now we'll do some data visualization. So the categorical data can be visualized by using a bar plot, and uh, the numerical data can be visualized by using a box plot, or what we can say, by using a histogram. You can check the distribution. So we'll check the for item weight. This is a sample one. You'll see this histogram, and I'm running this for loop for the all the numerical columns. I'm plotting the histogram. You will see hist is there. Okay, so you will see the data is not normally distributed. This is the right skewed. Here is also right skewed. Okay, these values. Okay, no issues. We will visualize the categorical data. So categorical data I'm visualizing by using a bar plot. So I'm using sns.count plot and giving this column name simply. Same thing, you can do it for item type. You can see the most of the items present for fruit and vegetables. You can check the establishment year. Maximum outlets established in 1985, and same number for rest of the years. Lowest is in 1998. Outlet size, you can check. The small outlet size is maximum. Then outlet location based on the tier 1, tier 2, tier 3 is the tier 3 is maximum number, and outlet type is supermarket type 1 is maximum one, right? This is all about the visualization. Then correlation matrix will check whether there is a the attributes are correlated or not. I'm checking for the numerical one. So numerical, here you will get the matrix where the percentage. Here you can see there is a 56%, that is a sufficient, not a significant correlation, but the maximum percentage correlation for the item MRP and the outlet sales means MRP is depends upon the sales. Outlet sales is depends upon the MRP. So we'll check the heat map of this also. So you will see here the 56%, 57% and the correlation among these two variables, right? We will plot the scatter plot also for these two values, item MRP and item outlet sale. Okay, fine. Our data is clean data now. Now I am dropping this item identifier here from the data. Yes. Now next thing is the feature engineering, because most of the columns are categorical one, so that we have to convert into the numbers or the labels. So I'm using a label encoder from pre-processing and creating the object, and I'm applying directly to this categorical columns. So le.fit underscore transform, and I'm using the for loop for that. You will get the data is look like this. So you can see this data. Okay, so everything is a numeric one. But the thing is that you will see the numerical data. There is a continuous values are there. The item weight, item visibility, MRP, and the establishment year. These columns are on different scales, but regression is distance-based algorithm. So we have to rescale these values. So first what we'll do, so we'll split the data into X and Y. So here you will see the X is the predictors and the Y is the target variable. So target variable is the outlet sales and rest of all are the independent variables. So data is split into two. So our X values are here. So except this column, right? So for the feature scaling, I'm selecting these because already rest of all are the encoded that cannot be used. So for feature scaling, I'm using these four columns and I'm using a standard scaler here and creating the object of standard scaler and I'm applying these one by one to each feature. Okay, now our data is ready with the scaling. So now these columns are on the same scale. Rest of the columns are the categorical one. Okay, great. Now you have to split the data into training and testing. You will see 10 test split I'm importing from the model selection and I'm using 20% data for the testing and 80% for the training. Okay, great. Now the next important part is model development. Here we are developing 8 models, right, from the linear regression, rigid regression, lasso, decision tree, random forest regressor, support vector regressor, extra tree regressor, and k neighbors regressor. Okay, let's start with the linear regression here, and I'll show you how to develop this model. So I'm creating the object of this. Then I'm using a training, that is a dot fit x train y train, and I'm using a predictions dot predict, right? And y test. You will see now this comparison you can do. You can evaluate this model by using R2 square score, and this one is mean squared error. Okay, so R2 score is 51.51 means 51% accuracy of this model, and this is the mean squared error, this much. You can do the cross validation by using this. Here I'm using a 5 folds. Here you have to import the cross val score, this function, right? This, and here you can take a mean of this. So 50% means it's a good accuracy, right? Now I'm using it for the linear regression. I'm combining this code and so that I'll get the good visualization of my results. I'm using for linear regression, then I'm using for lasso and rigid regression also. 51%, 51.58, then I'm using for lasso. Then I'm using for the decision tree regressor here. The same thing we have to do of 22% less accuracy. Then I'm using a random forest regressor is here from ensemble technique. It's an ensemble technique. You have to wait because it will create a multiple models. Yeah, 55.55. Okay, great accuracy. Then I'm using a extra regressor. Uh, okay, 52.65. Again, it's a good one. Then for the k neighbors regressor, it's a 48. Support vector regressor. Oh, it is giving a negative, but it's not a good model. So best model is which one? It's a random forest, right? Random forest model. So I'll use that random forest for the cross validation, and I'll check the what is the mean accuracy of that cross validation. So it will give the 5 accuracies, and yes, it will take certain time because yes, it's an ensemble technique, so we built multiple models based on the number of n estimators, right? And finally, you will get the accuracy is 55.18. So yes, it's a good accuracy. Then we'll check the feature importance for this random forest model, because which features are important from the target variable is concerned. So here you will get the graph. So most important feature here in the data is item MRP, then outlet type, and the item visibility and the item weight. So based on that, you can select the features also. So that is the we are having a functionality there in the random forest regressor where you can find the feature importance. Okay, and you can select the best features. Okay, great. We will do the model predictions because we are having these columns. So we are to input these values from the item weight 9.641. You can select low, item fat content is 0, this data. So this data I'm creating, this data is converted into, these values are converted into tuple, and here I'm converting into array. Then I'm reshaping this array because we are using a single uh, input data, right? So this is our data. This data is used for the prediction. So I'm using a random forest dot predict this reshaped data, and finally you will get the predictions. Now the sales prediction by the model random forest model is for this particular product is 4991 for this particular outlet. Okay, and for this particular type of supermarket. Okay, so the sales for that product will be 4991. So this is all about the building a regression model by using 8 different models. Okay, so that's all from my side. If you like this video, then subscribe my channel and share this interesting content. Thank you. Thanks a lot.